Welcome to this hands-on guide on securing web applications on Kubernetes using TLS, powered by the AWS Load Balancer Controller and Traefik. In our previous guide, we used the default load balancer service type in Kubernetes to expose our application over HTTPS with ACM, but that setup used older AWS load balancer types like the classic load balancer or NLB. These lack features like path-based routing. In this video, we'll upgrade to a modern production-grade setup using application load balancers, ALBs, managed by the AWS Load Balancer Controller, and integrate them with Traefik as our Ingress Controller. The AWS Load Balancer Controller is a Kubernetes controller that automatically provisions ALBS or NLBS based on ingress or service resources. This gives you a managed, DNS-backed, cloud-native way to expose Kubernetes apps using ALBS, which support advanced features like host or path routing, TLS termination, and tagging. Here's what we'll do. Install the AWS Load Balancer Controller, install Traefik using node port, create an ingress resource to provision an ALB, update Route 53 DNS records, verify TLS access. Let's dive in. We start by adding the AWS EKS Helm chart repo and updating it. Then save the default configuration for version 1.14.1. We need a service account with appropriate IAM permissions. Verify it exists with this command. We now customize the values file. This tells Helm not to create a new Kubernetes service account during the installation of the AWS Load Balancer Controller. We're setting this to false because in the previous step, we already manually created the service account using EKSCTL. Then install the controller. And then make sure it's running. In this Traefik configuration, we're exposing ports using node ports so that the application load balancer can route traffic directly to the Kubernetes nodes. We set the Traefik port to 31080 so that the ALB can perform health checks on the /ping endpoint. This is important for the ALB to know if Traefik is running properly. The web and web secure ports are exposed on 30080 and 30443. These handle regular HTTP and HTTPS traffic from the ALB. The service type is set to node port, which is required because ALBS can only forward traffic to EC2 instance ports, not directly to pods. This setup allows the ALB to send traffic to Traefik and check its health, all through the node ports. This is a Kubernetes ingress resource that tells the AWS Load Balancer Controller to create an application load balancer, ALB, for Traefik. The name of the ingress is Traefik ALB, and it's created in the Traefik namespace. The ingress class name is set to ALB, which links this ingress to the AWS Load Balancer Controller. The annotation section defines how the ALB should be created. Load balancer name sets the name of the ALB in AWS. Tags attaches metadata tags that can be used for tracking or Terraform automation. Scheme set to internet facing so it can receive traffic from the internet. Target type set to instance, which means the ALB will forward traffic to the Kubernetes node ports. Health check path set to /ping, which is Traefik's health check endpoint. Health check port set to 31080, which matches the node port exposed for Traefik's health checks. Listen ports specifies that the ALB should listen on HTTPS port 443. Certificate AINE points to the ACM certificate used for TLS termination. In the spec, we define routing rules. The ALB will handle requests for *.servicefoundry.org. It matches all paths, and routes them to the Traefik service on port 80. This configuration makes Traefik securely accessible via a domain like https://dev.servicefoundry.org through an ALB with TLS termination. On this screen, we can confirm that the application load balancer, named Traefik ALB, has been successfully created. You can see its status is marked as active, and it is configured as an internet-facing load balancer. Under the Listeners and Rules section, it shows that this ALB is listening on HTTPS port 443, meaning it accepts secure traffic. It is also using a TLS certificate issued for the ServiceFoundry.org domain, ensuring that all traffic to the application is encrypted and secure. This confirms that our Traefik service is now accessible over HTTPS using the ALB provisioned by the AWS Load Balancer Controller. On this screen, we're looking at the tags that were automatically added to the ALB named Traefik ALB when it was created by the Ingress resource. These tags include the EKS cluster name, the Ingress resource type, and custom tags like the service provider and service name. They appear here in the AWS console under the Tags tab. These tags are important because they allow tools like Terraform to easily query this load balancer and associate it with a DNS record, making the automation of DNS updates much easier later on. This screen shows the target group named K8S-Traefik-Traefik. It uses the HTTP protocol and listens on node port 30,080. 2 EC2 instances are registered as targets, and both are reporting healthy status. This confirms that the application load balancer is correctly routing traffic to Traefik running on each node. In the Health Checks tab, you can see the configuration used when the ALB ingress was created. The health check uses the HTTP protocol with the path set to /ping and port 31,080. This ensures that Traefik's /ping endpoint is checked regularly for availability. The timeout is 5 seconds and the check runs every 15 seconds. On the Route 53 page, we can update DNS records to associate our domain with the new load balancer. Here we're mapping ServiceFoundry.org to the ALB using an alias record. This allows Route 53 to route traffic directly to the ALB without needing a fixed IP address. Once DNS is updated and propagated, open a browser and navigate to https://dev.servicefoundry.org. If everything is configured correctly, you'll see your app served over TLS, routed through ALB into Traefik, and finally to your Kubernetes service. We've successfully installed the AWS Load Balancer Controller, deployed Traefik with node port, configured an ALB ingress with TLS, verified DNS and HTTPS access. This is a modern, secure, and production-ready way to expose Kubernetes web apps using ALBS and GitOps-ready Helm charts. Thanks for following along.